All right, let's do one more example of an optimization problem. It's got to do with, in this case, it's from a text. It's given a product, minimize the sum. That's the title of it, I called it. But look at the number here. I'm going to put it up on the screen. I'll put it on my iPad. All right, so the main idea here is that where you got optimization problem, you typically have two equations in the situation that you're given. In this case, we got the product of two positive numbers is 784. What is the minimum value of their sum? There's a product equation and a sum equation. So we have a product equation, and that's of two positive numbers. I'm going to call them x, y. And we have the minimum value of their sum. We got a sum equation. So stop and think. Again, one is a constraint and the other, a constraint equation, and the other is the equation we're trying to optimize to find the minimum value of. So we're trying to find the minimum value of their sum. So this is going to be the one we got to take the derivative of. So we go to the other one and recognize that that is a constraint equation. 784 goes here. And now what we can do is solve for one of the letters, and I'm going to choose y again. And we end up then with an equation, and I'll convert that to x to the minus 1 over here, so that the sum equation, and I'll call that even s of x since I'm getting rid of the y, equals x plus 784 x to the negative 1. That puts it in a format now that I can take the derivative of it. So I'm going to need to take a derivative, set it equal to 0, and solve for x. And remember that I need the answer is what is the sum, the minimum value of their sum. So x isn't the answer, the sum is the answer. So let's take the derivative first. Derivative of x is bring the 1 down, x to the 0, that's it. And then we've got a minus 784 x to the subtract 1, negative 2. That gives us, I'm going to rewrite that as 784 over x to the second. Now what I'm going to do is I'm going to set this equal to 0 and solve for x. So I end up with, I got a minus sign there. If I take it across to the other side, I've got this, which is 1. Now if I multiply each side by x squared, I've got x squared equals 784. And a quick check on the calculator gives me that the square root is, now mathematically, this could be plus or minus 28. But we're told that it is two positive numbers in the problem. Therefore, positive 28 is the solution. Remember, x28 is not our answer. We need to find the minimum value of the sum. So I plug it back into our equation solving for y, and we've got our x now being 28. And that ends up giving us 28 since it is squared. So we've got y equals 28, x equals 28. Therefore, the s equals 28 plus 28, which is 56. So the minimum sum is 56. Answer. Thank you. That is another problem, optimization problem. Keep practicing.